Yeah, that is 3.3 volts.
Okay, and this whole thing wants 3.3 volts? All right.
Okay, we're back live again. No viewers. We had to drop them all and restart.
Okay, so David, this is not working. However, let's see if we put this P59 pull-up in.
And we've got 7 people back already, 8. Loading in the audience. Participants, everyone's coming back. Sorry for the hassle, guys. How's the video and how's the audio? So prior to our disconnect, Chip wrote a program to toggle an I/O pin, and then we looked at it on the scope, and it worked beautifully.
That's P59, right? We're pulling it up.
There are no Wi-Fi cams running around here.
Complexity around the.
Okay, good. So we have good resolution. Audio is good. Current consumption. Right now, nothing. Oh, we just picked up Ozprop Dev. Things are waking up.
What am I missing? Okay, so we need to know, okay, do we even have like 1.8 volts and all that?
I checked. It does.
It does what?
It does. 1.8 regulator does work.
Okay, so then we're going to see. Okay, good.
Checking the reset.
Now we're just looking at the voltages. Oh wait, David, did you? Oh, you did connect. Oh, wait a minute. What was this here?
3.3 BC.
Oh, it was.
You guys are using a pick and place board now, right? Yeah, we're back to the pick and place PCB.
All right, well, this, for some reason, David, I think that Peter's got an extra inverter in here, you know, that we don't need. See?
Yeah, do you want me to bypass it on one of them?
Yeah.
You want to place a few more?
This guy, and then swap, use the cable you had.
Well, this has this has a pull down generator too.
No, I bypassed it.
Oh, you
yes,
did? Oh,
the
okay.
pickers.
Did you just do that?
Passed for sure. The pickers made this go. To see an I/O pin toggle.
Oh,
You missed it.
All right. Let's see here.
We'll bring it back for you, Heater.
Okay, and then reset is the next one. And then TX
Going for a download. Something not quite right.
we might just
TXRX.
and TX.
Okay. Switching those two guys around.
All right, let's look at the reset on this one.
Reset Chuck.
Oh, reset's like,
I just saw a high signal.
it's like pull low.
Yeah, it's
Let's
opposite.
pull this out. David, this thing has reset just pulled constantly low. Hey, David? Well, no, reset should always be high until this thing pulses at low. So this thing, well, yeah, I think Peter's board has an inverter on it.
USB 6 reconfigures it to reset. I have done that at some point.
Wait, say what?
You can set the FPGA chip to invert and use the outputs.
Oh, okay. Well, this, because this has the inversion circuitry, I don't think this thing's going to work. Roy.
Somebody in the forum has been saying that the circuit on Peter's board is backwards for reset.
Yeah, well, I notice it has an extra inverting transistor setup in it. And so,
Right. It's backwards.
Well, you mean it's inverted is what you're saying.
Right, yeah, it holds it low instead of high.
Right. Yeah, we got that. Yes. Okay, I can see that in a schematic. In the boards I hand built, I just bypassed it and made it compatible with the prop plug.
Yeah. I understand.
That seemed to work.
I was just conveying, they've been saying that for like the last hour that Peter's board has the reset.
Oh man, I'm sorry. Those poor guys. Because I'm just looking at this, not really looking at their feed. But you know what?
Yeah, it's fine.
Okay, we got this thing.
We know the chip works.
Yes, but it's a very strange thing. It seems to work, but wait a minute. Hold on, wrong board here. Oh, I got the wrong board. Where's my other board? Wait. David.
Yeah, it requires a
Right here.
resistor on P59.
Yeah, but why? I mean, I know that tells the ROM to go immediately to serial, but I'm trying to remember, did we make it so that that's how it works, is that it doesn't talk?
So in your docs, it says no connection equal to serial and then timeout.
Right.
But it also says that P59 pulled up enable and then fall back to SPI, and it forces it to be serial first, and without anything, I think if you rise SPI first and then fall back,
Oh, then it crashes. I think it I forgot about this. It's a forget these days. Yeah, I think if it tries to do SPI and it doesn't work, it just goes to sleep, right?
That might be the case. I'm not really sure. I'm not sure of that detail, but I seem to recall that you want the default case for it. There was like all this discussion about the default case should be as fast as possible, was just like from Flash.
Right.
But then if you wanted to, you could do something to get the serial.
Yes. Okay. So, all right. Okay, then what we've got might be okay. But I just, on a lark, kind of put that P59 thing in there, and it started working like I'd expect it to. So now I'm hooking it back up. Are you watching?
Yeah, I'm watching.
All right.
I just haven't muted it because it's like,
Oh, okay.
we're talking and the video is like a minute behind.
All right.
You know.
Okay, now it's not working. Let's see. Oh, hold on. I don't have a prop plug. I have a USB to C here. So many little things to get twisted around here.
Yeah.
Okay, so this should do it. So you see this configuration here. F11, it loaded a program. And then I think it's like right here. Look,
Check that out.
it's just a program that toggles the
Wow.
pin.
Look at that beautiful square.
Yeah.
That's the prettiest thing.
Oh man, I don't remember how I made the ROM do that. I know that.
Well, you're gonna have to go look at the ROM source code again.
Yes, that's what I'm gonna have to do. I just can't. I guess I've been thinking about so many things that I'm not even like, okay, that detail's done, put it, move on, and then I don't remember how it worked.
Yeah. You've been working on.
Yeah, and slowly. So, good thing this thing's about done.
Yeah, and I think you need to get maybe to where you fix the inverted
Right.
circuit.
Well, what we do is we just bypass
Skip
it.
it.
We just skip it because it's just throwing an inversion in there that we don't want. So all we do is just skip it.
Yeah, I was gonna say just remove the transistor and bypass it.
That's what I did on my little board. Yeah, I just bypassed it altogether.
So do you want Dave to finish the rest of the board so we could get done with this? For David, Chip?
Yeah, you could build the rest of the board. We're going to have to, you might as well not mount all that. Or actually, no, go ahead and do it because he's going to want one. We can desolder the parts later. But Peter's going to want one, and so will Clouseau that has that feature. I mean, he designed it for some reason, right?
Right, but I think you probably meant for it to be the other way around, right?
Well, I don't know. I mean, maybe he has his own.
He's probably using off-the-shelf breakout.
Yeah, he might be using some off-the-shelf breakout board or US.
I think Chip's thinking it might be easier
serial
just to put all the parts on and then take those inverters off and bypass
All
them.
right, so let's see P0 do some analog stuff.
Okay. Peter
Let's
says
see.
0 pin, 1 megahertz will output a square wave on P0.
Oh, okay. Hold on.
wanna
Let's
see that?
try that. Yeah. Let's see though.
Okay, I'm gonna let you go again.
Okay.
Thank you, Roy.
Thanks, Roy. Okay. Bye-bye.
Bye.
Okay. Thank you, Roy. Okay, so now we're gonna.
Are we gonna do an analog program?
Well,
Okay.
let me get back into this thing.
Peter, this will be your first program.
Okay, let me just save this.
Keep your font big and fat so we can see it.
0. All right, so Peter, we're gonna go into here.
Move your USB cable out of the way a little bit. I'll come around the other side.
Well, here. All right. So here we've got the Parallax serial terminal, right? And we're gonna. Oh, we need to reset. So let me do a reset pulse to stop the chip. Okay, now we can talk. So I'm going to say greater than space prop check 1 2 3 4, and it comes back with prop version A. Then we go escape. We're in tacos. Now, what do we say to make a signal on P0?
Okay, he says 0 pin, 1 megahertz.
Like MHC?
Yeah. 0 space pin space 1 space MHC. Will output a
0
square
pin.
wave on P0.
Like I typed right there.
Yeah.
Okay, it didn't do anything.
0 space pin
0
space 1 space MHC.
Wait. 0 space 1.
No. 0 space pin space 1
And then
space MHC.
oh, there it goes.
Okay.
Yeah, look here now.
How do you guys like that? Yeah, caps.
Okay, that worked. That's good. All right, so that's working. Let me see. Now I can try to do some analog stuff here. What do we call that? We had one little program. Trying to remember the name of that old program. Oh, it's got to be up here. Which did, was it called DBS or something? It was in the file set. Let's do this.
Definitely relieved.
I wonder if we try to run this.
Financially, we're not interested in another round. That's what this means.
Oh, don't say that, Ken.
Well, I mean,
We got some property we could sell.
what are we expecting, Chip?
I'm looking for an analog signal. 0. Let's see here. Okay, back up a little bit. Let me just see here. So DAC mode 4 and 5. Turn them on.
Chip, you have the wrong regulator package.
Oh, this needs a crystal. What, David?
The regulators are available with in and out swaps. We have the opposite of one.
Well, what are you saying? If we put it on, it won't work?
So the reason they're not regulating is because they're getting tripped back.
Because they're what?
So the in and the out are swapped on the 3.3 volt regulators.
Oh, well, then let's don't put the regulators on then.
Yeah.
All we need is what I built here.
Yeah.
It's just support, and then there's some extra stuff like, you know, the SD card and all that. But that's specialty. I mean, to be able to talk to these, we don't even need power supplies. We can use bench supplies for those.
Anyway,
This
you're ready to go. So do you want me to build it without the reset circuit?
Build it without reset?
Yeah, just bypass the reset and bypass the regulators. If there's any issues with it, just put the caps on. The bypass caps are all good. And but we don't need regulators, and we don't need anything that's going to make it not work right.
So we're looking for an analog program now?
Yeah. Well, okay, stop.
Stephanie offered if we want any food.
Ooh.
You guys need dinner? You've had this for a very
Yeah.
long time.
Sure.
David, what do you want? What do you want,
What do
Stephanie?
you eat around here that's not going to kill you?
I'm done. I'll just make sure I get it.
Stephanie, you don't have to worry about us, really. We'll be
Yeah,
around
yeah,
this
we're
store.
Are
okay.
you kidding?
Yeah,
Of
no.
course.
Should be worried about
All
you.
I've been doing is holding the computer.
Only there's
Yeah.
nothing I can do for you in this part of the
I think we're
process.
fine. Because
Yeah,
we're
don't
actually
worry
going to
about it.
place one more board, then wrap it, right?
Probably, yeah.
Yeah. So a very kind soul
Yeah,
showed
look,
up
It's running.
to offer us
But
some food.
It's acting a little weird. Maybe it's how I left this code. I don't really remember. But we made some last minute changes to the sequence, the way the ROM works. So with this pull-up resistor on P59, it seems to be working. And that's
Now we're
neat.
going to build a few more boards.
Where's the confetti?
It happened online. There was confetti thrown.
Was there confetti?
Champagne was popped from Australia to Finland.
I missed that. I was busy watching Jill Bertha Parallaxy on.
Roy says hello.
Hello, Roy. Tell him I love his xylophone.
Oh, the xylophone, Roy, is totally cool. I got to see it today. So should we roll over there and see this now on the scope? What do we got here?
Anything yet.
There's something.
Oh, wait, there's something, yeah. Wait, what is that?
That looks like
See, these are all like
nervousness.
just old hacked programs that I didn't.
Oh.
I'm not sure where I left them off.
So Chip, how would you characterize the known state of the P2?
Well, okay, I don't know that there's anything wrong with it. It looks like it's definitely doing some things, everything we've asked it to do, but I got to go and review the way the ROM works. I didn't remember that we had to have a pull-up on P59 to be able to talk to it. That's kind of new to me. I mean, it's not, but I guess I just forgot. But the plan was that if there was nothing, it would just wait around for a serial conversation, but it doesn't seem to be waiting. I don't know why.
Okay. Definitely want to get P2s to all of you. We have more parts coming that will get packaged up from Amcor. And then we have to decide what we want to do. Do we want to pick and place more boards, get more parts? Maybe David would order Peter's board. So we'll figure that out next. Maybe tomorrow we will decide, give Chip a little more time here to play with us. And David will give him a few more spare boards to work with. And then Chip will make a decision about those 100 chips. We're getting ready to see another one come off the line. P2D2 is one of the best names I've ever come across. So this would be the third board assembled today. David's overriding errors and just making this thing get the job done at this point. Oh, there it goes. Out to the side. Grabbed it just before the oven. Looks like he's going to let it go. Safe travels, P2D2. We'll just watch this one head into the reflow. Then we'll get him out the other side. Go back and visit Chip. One more P2 on the P2D2 board. This will probably be the second successful circuit we have built today. Good luck in there. Bye now. Okay, and off it goes. Harry, the current status is we have a running P2. Okay, now it's got to travel through this long chamber. And eventually, come down here and get it. But let's take a look at how Chip is doing. He's telling Stephanie about the analog or lack of analog. We don't know yet.
Well, I was hoping this would be it, and it looks like it might be it, but I now got to review the log book and see what it's doing, but I don't remember what it is. It should be that it's not an anything, but it's a serial. It's like hard for me to work because I don't have all my files and all my papers, like it's all around it.
And then just having just one little monitor is like keep your
Yes. Yeah. Did you ever see the monitor?
No, but I imagine they're just like it's still on the wall.
Yeah, I got Walmart. They're selling TVs.
Okay, so we'll check in with Chip in a moment on the analog example. Whoops. Let's see if it worked. Things are falling apart here.
And I don't run them before they get stuff in. And it's like everything.
Try to secure this display a little better. Okay.
This, and now it's like I can see before the you know, it's keep the screens for everything.
Yeah.
Thanks for the offer.
Find your blood sugar dropping too low. I have my protein vegan meal replacement shake
gosh.
powder on
I
my
might
counter
go
with
for
a
it.
shaker jar.
Thank you. That's super tempting. Wow.
Oh.
I'm fine. I'm waiting. I think we're gonna wrap it up
What's
actually and send him home because he has to go home tonight.
What's this one? Oh, this is the one you just.
And David's doing the second board right now.
I just know that.
Oh yeah. You reach for the easiest access. Yeah. Thank you. Okay. See you.
Thanks a lot. We'll see you later.
Yes, we owe a huge thank you to David for getting the PNP up and running today, because if he didn't build that board, we might still be struggling. And now there's a second one in the oven. And to the third one coming? Okay, a third one going. There are two. Oh, okay. So he's only limited by the PCBs now. We should have cigars. I think for Chip, we need to hand out plants, though. Got an analog? Almost. We're still waiting for this analog, then we'll go get a look at it.
Let's see.
Yeah, David did an excellent job getting that thing going today. He didn't even know he was going to do this today, and I derailed him at 11 a.m. or 10 a.m. and said, "Can you?" And he did it. And for Kenneth Glass, who helped him out loading up the reels, and for Jeff for bringing us lunch, and Roy for helping us solve the double pull-up inverter, whatever.
Oh yeah.
Analog?
There we go. Yeah. Look.
Analog. Analog is here. Let's get a look at some analog. Okay, I can't see anything because of the glare, so.
Wait, hold on here.
What are you expecting this to look like?
This is NTSC.
Hang on, Heater. Don't go to bed yet. We're looking at composite video.
And set the trigger.
What was the max current draw for the high power program that we observed? Chip?
The what?
The max current draw for the high power draw.
Oh, I don't know. It was just getting funny. We're running over these cables, and you try to.
We don't know.
I have to make a better setup.
So as soon as Chip gets this NTSC bit straight on the scope, we'll get in there and get a closer look.
You know, how in the world, trigger menu,
It's a scope
high
user problem.
edge, channel 1, falling, normal, DC coupling. There we go.
Jeff, I'm streaming from the Surface still.
Okay, why is this all over the place?
There's a better view.
Channel 1 menu, bandwidth limit. $20 megahertz. Just looks so loud.
Just a scope configuration issue mainly.
I don't know. I mean, there should be the, so we can stop. Well, you can see there's the signal, but it just seems so noisy. Oh, maybe I got just way too much. Let me try to make a sine wave.
Maybe it's the code Chip's got here, but the composite signal looks kind of messy, so he's going to make a sine wave instead.
Let's see. Okay, then I gotta go.
Okay, so question for the viewers, just planning ahead. Suppose this checks out all okay, and in a couple weeks we've not found any problems with the P2. How would you feel about coming to Parallax for an expo in April?
There we go.
It would be a 4-day expo. First part would be the Blockley World Summit. Look at that sine wave. And then the second.
Stop. So look at that, right out of an I/O pin.
And then the second part would be a Propeller expo. It'd be 2 days of each. 2 days for education, 2 days for the Propeller. You guys would like that? Okay, okay. So I'm just waiting for Chip to give the word that we can plan that.
Yeah, I just got to check the chip
He needs some time with the chip, but
and make sure it's good.
it has a lot of advanced planning because we have to get approval from everyone from the fire department to the city of Rockland, and then secure the hotel room for everybody and get the food trucks, because 2,000 people here in a day.
No.
We had 2,000 last time.
Well, that was a community kind of event.
Yeah, that was coupled. That was the expo.
This would probably be 100 people.
No. We're going to couple this with the Blockley World Summit.
Oh, Blockley World Summit.
Which we're hosting.
Can we deliver on that? That sounds pretty
do you know about the Blockley program?
So you can see there, there's an I/O pin outputting nice analog. That can be like 75 ohm 2 volts, or 123 ohm 3.3 volt. There's also a 600 ohm 2 volt or 990 ohm 3.3 volt option for the data.
Some reason, I think Phil Pilgrim would really like to see that.
Yeah,
it's too bad he's not online.
Lachlan does too, and then we can correlate that with the Gortzel algorithm, and we can pump it out one pin, measure it coming in on another for amplitude and phase delta, and do all kinds of interesting signaling, through all kinds of media. Sure. Do measurements and resonance checks and all kinds of fun stuff. So here I could summarize where we're at.
Okay, let's do that.
Right? Okay.
Yeah.
So summary is the chip seems to be working. We don't know that there's anything wrong with it actually. It took a long time to get going today because of possibly some ground issues, and then later maybe wasn't remembering right that in order to have a serial conversation with it, we need to put a pull up on P59. So we did that and it worked. I thought the ROM was, if there's no pull up at all, it should have a conversation right away. But whatever, it seems to work, it seems to do everything. I have a lot of testing to do with it, but there's no indication there's anything wrong with it. I'm just a little miffed. I don't remember how the ROM's supposed to work. I might be wrong there. I mean, I must be because it's not how it works. And on SEM, I checked it out and found all the digital stuff to be, in accordance with the design. So looks like it's okay. So we're going to build a couple of these boards here. We're not going to fully populate them with everything because some of the stuff gets in the way of testing. But I'll be running through this thing the next week or two and just going over everything and wrong with it. And then if it looks good, then we'll start producing these things. And I've still got more work to do on the development tools. And any of you guys would be awesome if you want to make any tools. It's open, we'll make some tools, but there's a lot of.
So Chip, what they'd all love to know, but they're afraid to ask, is when we get these 100 Amcor package parts.
Probably design a little board like what Peter did. It's got to be a little more spread out. This is too tight for me. I'm switching between eyeglasses, monocle, and then the mantis here to see anything. So I got to try to make it a little more old person-like.
So these people think I'm baiting them along with P2s. But one thing, we want to carefully track where they go. We have no problem getting them out for free to people. That's what we want.
To have them because if you can use them, then we can sell chips.
We want to get those chips in the hands of our users to start doing things.
And if you just had a good time playing with it, never made a product, I'd be just as happy. But it would be nice if we made some money too. But that's not incumbent upon anyone.
We aren't going to make money with 1,500 chips.
Happen out in the world. But
yeah.
This thing's mainly something that should be really fun to build with and design with, and won't hold you back and let you go all the way to the basement and and understand everything, and kind of like nothing seems to be anymore.
Yeah, we want to get chips out to all these people: Whisker, Prop Stuff, Roy, all of them, on a board of some type. It'd be nice if we could pick and place them here or there.
Yeah.
Peter's board is imperative for getting us going today too.
Yeah, that totally helped out.
So we will do that. We'll manage them, kind of get a person in the office do it, so we know where everything is. So see on the forum, sending stuff out, we're going to send that back through somebody in the office who can keep track of it for us. So we have a process to go with it, right, Chip?
Sure.
Yep. Yeah, so we need to give Chip, Peter, we could use a few more of those boards in the meantime.
Peter, do you remember, can we not have a serial conversation with this thing unless we put a pull up on P59? I thought that, I must have known, but I've forgotten things.
Well,
because we made a lot of changes at the end about how the ROM behaves. If there's no pull up anywhere, can't we just by default, isn't it supposed to wait around for a conversation? Or does it do something where it shuts itself down really quick? It seems to shut itself down really quick. But with a pull up on P59, it hangs around for 75 seconds, which would be at least 60 seconds running at 30 megahertz. And because this thing runs at 25 megahertz on the desk, but should never, with process voltage and temperature, go below 20 megahertz. It'll always wait at least 60 seconds, but we accurately measured 76 seconds. I was expecting 75, but that's
Peter's notes say,
perfect.
Try serial if no pull down on SPI DI.
Wait, try serial.
He says, try serial if no pull down on SPI DI. Data in, I guess.
If no pull down.
Yeah. I don't want to be your interpreter. So you guys are going to have to chat.
I just have to
all right?
look at the code. If
Yeah.
I look at the code, I'll know because I'm just not remembering.
And
'Cause we
Cluso
made
says he'll
some
look at the code
changes,
too.
and then I moved on. I didn't really remember all that. So this stumped me for most of the day probably, is not realizing I needed a P59 pull-up.
Yeah, okay, so priorities then. Chip teams need some time to work with this. We need to sort out what we're going to do with the chips soon and whether or not we pick and place them. Then there's the interpreter, right?
Yeah, that's what I've been working on.
And what else?
Jeff's
Jeff's prop tool.
A little board.
And data
Final
sheet,
board.
stuff like this.
Yeah, and I
Okay.
got more docs to write. Now that the chip exists, I can write docs on the actual pins. And there's some stuff to be covered there. Not a whole lot, but it's several pages of stuff.
Okay, what do you think? David, had enough?
Yeah, still looking for one more board.
He's still looking for a bare PCB. Okay, then we
I
could.
think did I throw one away or did I leave it over there? There's one.
Want to thank everybody for hanging on with us today. I know it's 8 hours of viewing.
Oh, this is the bad one, yeah. This is the one that got blown out. Yeah, guys, thanks for hanging around, and sorry it took so long to figure out that things do seem to be okay. I'm not even relieved yet because I'm so used to so many problems that I'm just pretty sure that, you know, nothing's going to work quite right. But it looks good so far. I've got, you know, no real reason to doubt everything. It looks like it's going to be okay. We just got to test it out, and we should have good chips.
All right. Thank you, everybody. And
yeah, thanks for all your support over all these years to make all these awesome inputs that were way beyond what I was thinking, but so much of your stuff got, you know, implemented into this, and it's the coolest chip. I don't think there's any chip out there that's a microcontroller that probably has even, you know, 1/4 the thought that went into this with all these people over all these years, maybe even a 10th. But hopefully this will be fun, and we'll have years to play with it and make cool things out of it, and then make follow-on stuff that are variants, eventually make something else. I don't know if I got another one of these in me. I'm wearing down.
No. Maybe you don't, because you double your time on each subsequent project.
Yeah, the next project
will take 26 years.
Yeah, and I'd be 77 then, so I can't do that.
All right. Have a good evening.
Yep.
Signing off here. Good night from Parallax. Bye.